Hey everyone, welcome to The Explainer. Today, we're unpacking what is honestly probably the most critical shift in modern cloud-native architectures right now. We are looking at DevOps versus platform engineering, and more importantly, what enterprise teams actually need to be focusing on as we head into 2026. Let's get into it. So let's kick things off with a question that's been on pretty much every engineering leader's mind lately. Everyone talks about DevOps, but why are companies suddenly pouring massive investments into platform engineering? Like, did DevOps fail us? What's going on here? Well, the short answer? No. DevOps absolutely hasn't failed. But the reality is that organizations are facing some incredibly real business problems today. I mean, look at these pain points. We're seeing plummeting developer productivity, just massive tool sprawl across teams, highly complex cloud infrastructure that's a nightmare to manage, and as a result, painfully slow software delivery. So stick with me, because in just a few minutes, you're going to understand the core difference between DevOps and platform engineering, and exactly how they work together to solve this exact crisis. All right, here's our blueprint for today. We're covering 1, the developer cognitive load crisis. 2, where DevOps maxes out. 3, enter platform engineering. 4, DevOps versus platform engineering. 5, AI and the future. And 6, scaling your engineering culture. Let's dive right in. Section 1, the developer cognitive load crisis. To really understand why platform engineering is totally surging right now, we've got to look at the root cause of the pain the industry is feeling. And the research shows a frankly staggering number. Developers in DevOps mature organizations are now spending up to 30 to 40% of their time on infrastructure tasks, stuff that is entirely unrelated to their actual business logic. They're forced to juggle Kubernetes network policies, manage secrets, untangle deployment pipelines, and figure out security guardrails. You know, modern developers are just simply overwhelmed by this massive cognitive load. They're basically doing operations work instead of actually writing features. Section 2, where DevOps maxes out. This brings us to a really crucial reframing of the narrative here. DevOps didn't fail. It really didn't. It was just designed for a specific stage of organizational maturity, a stage that a lot of enterprises have simply outgrown. Let's get clear on our terms for a second. DevOps is fundamentally a methodology. It's an essential set of cultural practices, principles, and automation patterns that bridge development and operations to speed up software delivery. I mean, it introduced incredible game-changing concepts, CI/CD pipelines, shared ownership, that famous you build it, you run it philosophy. And honestly, when you have a 15-person engineering team, that mindset is incredibly liberating. But here's the catch. DevOps hits a major wall at enterprise scale. When you ask, say, 100+ engineers to each build and manage their own custom pipelines, you end up with massive tool sprawl across all these independent teams. You get that unmanageable cognitive load we were just talking about. You also run into knowledge concentration, the dreaded bus factor, where literally only 2 people in the entire company know how to fix a broken pipeline. And on top of that, you end up with completely inconsistent security and compliance workflows. Basically, that whole you build it, you run it mantra quietly turns your highly paid front-end developers into part-time infrastructure managers. And nobody wants that. Section 3, answer platform engineering. Okay, so how do we fix all this fragmentation? Well, we introduce a vital structural upgrade to that original cultural foundation. Enter platform engineering. This is a product discipline focused on building what's called an internal developer platform, or IDP for short. This platform basically abstracts all that underlying infrastructure complexity away so your developers can get back to just focusing on writing code and business logic. It emerged specifically to solve the massive fragmentation, tool sprawl, and frankly the burnout created by unguided, decentralized DevOps practices at scale. Now, a lot of the confusion between these two concepts really comes down to a category error. People mistakenly swap a culture for a structural implementation. Think of it like this. DevOps is like having every team manage their own kitchen. They have to build the stove, source the pans, and double-check the safety valves themselves before they can even think about making dinner. Platform engineering, on the other hand, is like building a professional central kitchen with standardized tools, pre-approved recipes, and built-in safety systems. The development teams still cook their own meals, they just don't have to build the stove first. Make sense? So the crucial point is how this actually works in reality, and it happens through what's known as a golden path. Instead of opening up Jira tickets and waiting around for days for an ops team to provision resources, a developer just uses a self-service portal. The CI/CD pipeline pre-configures automatically. Policy as code enforces all your security and compliance guardrails completely in the background. And the end result? You get a fully compliant deployment environment spun up in literally minutes instead of days or weeks. It's a real game changer. Section 4, DevOps versus Platform Engineering. All right, let's look at a layer-by-layer showdown to really cement the mental model between these two concepts. While DevOps aims for faster, collaborative delivery, platform engineering specifically aims to simplify that delivery at enterprise scale. Ownership is another big one. It shifts from a shared and sometimes vague dev and ops responsibility to a dedicated platform team that actually treats the platform as an internal product. Tooling moves away from individual CI/CD and monitoring setups built by every single team toward a unified, self-service internal developer platform utilizing those golden paths we mentioned. And most importantly, when it comes to scalability, where DevOps struggles with tool sprawl, platform engineering encodes compliance automatically into standardized, totally reusable workflows. To put a practical, real-world perspective on this, because I love concrete numbers, high-maturity enterprise organizations are achieving an incredible 20-to-1 developer to platform engineer ratio. Take the company's Sixt, for instance. They are supporting 800 developers with just 40 platform engineers. That kind of massive return on investment in developer experience, or DevEx, is virtually impossible if you're stuck in a fragmented, traditional DevOps model. Section 5, AI and the Future. As we look ahead to the urgent realities of 2026, there is one massive catalyst that is making this architectural shift totally mandatory. And you probably guessed it, artificial intelligence. The 2025 DORA report noted something pretty wild. They said more code generated faster, pushed into fragile pipelines with slow feedback loops, results in more incidents, not fewer. Really think about that for a second. AI coding assistants just amplify whatever state your infrastructure is currently in. If you have messy, manual deployments, AI is just going to help you break production faster. A mature internal developer platform acts as the necessary distribution layer to safely absorb and manage all that AI-generated code. But here's the cool part. AI isn't just generating code, it's actually enhancing the platform layer itself. By integrating intelligent operations, or AIOps, into the platform, teams are seeing huge reductions in alert fatigue. AI can correlate all that data and literally remove up to 70% of meaningless alert noise. That leaves your platform engineers to focus only on the 30% that are actually actionable. That is a huge weight off their shoulders. Section 6, Scaling Your Engineering Culture. So how do you actually sequence these two disciplines in your own organization successfully? Well, it's not an either-or decision, right? It's about sequencing your evolution based on your specific size and pain points. If your team is under 50 developers, absolutely start with a strong DevOps culture and basic CI/CD. You really don't need a massive platform just yet. But once you cross that 50 developer threshold, or honestly, when you start noticing onboarding taking weeks and duplicate tools popping up everywhere, it is absolutely time to layer in platform engineering. You need to build the platform as a true product, using actual developer feedback and user research. Implement a hybrid model where a central team provides the core tooling and the application teams consume it seamlessly. If you take away just one thing from this explainer today, let it be this one memorable sentence. DevOps builds the delivery culture, but platform engineering builds the platform that makes that culture scalable. I'll say it again. They are completely complementary forces. Which leaves us with a final, kind of provocative question to ask about your own organization's productivity today. Ask yourself, is your engineering team spending more time building the kitchen or cooking the meal? If this explainer helped you understand the difference between DevOps and platform engineering, please like, share, and subscribe for more AI, cloud, DevOps, Kubernetes, platform engineering, and software architecture tutorials every single week. Thanks for